Good afternoon, and thank you for joining us for today's Kenworth Northeast Training Academy. Today, we're going to take a deep dive into drive shafts and failure analysis. My name is Melinda. I'm the Director of Marketing here at Kenworth Northeast, and more importantly, we're joined by our trainer, Scott Greenwald, and also Ken Williams from Dana. So cameras and audio are defaulted to off to reduce our background noise during the session. If you have any questions, please pop them in the Q&A anytime, and we'll make sure to address them throughout the call. And of course, at the end, we'll also check in for questions as well. In addition to today's training, we've got a great lineup of events this year. If you've not had the chance to check out our other sessions, you can find them online at www.kenworthne.com/events. So with that, we will go ahead and get it started.
All right, let's share. Is that coming through?
Yep, I can see it.
All righty. All right, first, let me introduce myself. My name is Scott Greenwald. I am the training manager for North America. I spend the majority of my time out in the field working with technicians, working with counter folks to better understand Dana Driveline systems. And that's not only specific to the drive shafts and drive lines, but also the steer axles and drive axles. A few things that I always like to cover to make sure that we're aware as a group what all resources that we have available to you aside from doing these styles of live webinars. We have training.dana.com. That's another resource that you can take a look at. Is my presentation coming through, or is it only?
I can see it.
Okay. So we have that which has got a handful of learning paths. It's all self-paced. It doesn't require any kind of paid subscription, so it's free to use. Great resource for you to either freshen up yourself, or if you have somebody new to the industry who is looking to learn a little bit more about component identification, things like that. We do offer light vehicle, commercial vehicle, and some electrification training as well. Throughout the presentation, I do have one spot where we've got a little AR. It's this yoke measurement and Spicer ruler usage. So we do have those that are kind of a little bit more on the techie side, trying to bring some new ways into training that are more visual and may better let you understand how to use some of the resources that we have. Of course, training aids, and there's plenty of different videos and webinars. And then, of course, our Spicer ruler, which we will touch on, and then say the angle master as we kind of move through this presentation. So today's focus is going to be really just on Driveline. We're going to be covering the basics. We're going to be covering maintenance, angle measurements, and then wrap things up with failure analysis, and then also a few of the programs that we have available through Spicer to help you identify some part numbers. So in starting with the basics, really it's making sure that we all understand proper nomenclature. And for me, I like to really start at what is ground level, and that's understanding the differences between a coupling shaft and a drive shaft and an inner axle. So the first thing is the coupling shaft, which is connected to the driving unit. It does not have a slip joint. It will have a center support bearing and only one U-joint. Behind that, we'd find the drive shaft, which is connected at the center support bearing. It always includes a slip and will have two U-joints. And then we finally have the inner axle, which is between the axles. There are two different styles of inner axle drive lines. We have a short couple or an inner axle. We can identify those really based on visual, visual look of what these two components are. So the first one is if we have a 10 series, we would have two welds similar to the SPL. So if we find two welds on a inner axle drive line, that's how we would identify them. If it's a short couple, the 10 series would have no welds and the SPL would have a single weld. So as you're moving through and trying to identify, and help find part numbers and making sure that we're getting to the right part numbers to perform any kind of service on a driveline system, it's important to understand how you can visually identify the different components. Some of the more common components that you're probably more aware of would be center support bearings, U-joints, the end yokes, and the hardware. So we'll be moving through some of those individual pieces as we get through the presentation. But where I maybe like to start with is an example drive shaft. Some of the more maybe not so common components. So things such as the yoke shaft, the boot, a spline sleeve. We then have the tubing and a tube yoke. Again, most folks are familiar with what's a U-joint, what's the spring tab, the hardware, things like that, center support bearings. But some of the less common known parts are, listed here on the drive shaft. You may not be servicing these, in your shop, depending on what kind of setup you have. You may not have the ability to do the pressing and the welding, but I do think that it's important to understand which parts are serviceable and which components are not necessarily serviceable, depending on what kind of setup you have. The next thing I'd like to touch on is our smart numbering system specific to the SPL series. So each one of these component or part pieces of the part number identify a specific call out for that system. So if we're looking at the first three digits here in our SPL numbering system, we would find 250. Well, that's going to represent the series of U-joint or driveline that you're working on, whether it's a SPL 70 all the way up through an SPL 350. These first three digits are what's going to identify that. The second is going to be a descriptor of where at on that drive line is this component operating. So coupling shaft, drive shaft, interaxle, the jack shaft, or the short couple. So when you're working through part numbers, am I ordering the right component? Does this classification match where at on the truck we are trying to find this component? The next part, this is a little bit more in depth. This is the individual really makeup of what that drive line is. So 5-4, that means at one end we would have a U-joint, at the other end you would have an end yoke. So depending on the style, this is a little bit more in the weeds, maybe not as maybe something that you need to remember as much, but I do want to make sure that we call it out. The last part of this is what style of U-joint, which we'll cover a little bit later. We have our standard SPL, which has a grease zerk, and then we also have the Spicer SF, which is service free. So these will not have a grease zerk. So depending on the part number, this is one way that you can quickly identify, am I getting the right parts when I order it? The next is understanding driveline lengths. So we're familiar with that last part number now, that 250 CS part number, but we always see a number after the dash. And starting with the 10 series, we see this 0916. Well, that too means something, and that's going to indicate the length of the tubing as measured from weld to weld. So if we were to separate this driveline system into individual components, that dash 0916 is a measurement of 9 inches and 16/32, or half of an inch. On the SPL series, we would have a dash, for example, 0923M. That's going to be the same measurement as far as indicating how long it is. However, its measurement is going to be in millimeters. So you can convert that over to freedom units if you'd like, put that on the internet, and you can, convert that over so that you can use your tape measure and again verify that you're getting the correct driveline assembly once you measure it and find that part number. From here, U-joint identification, this is more of a visual inspection. Am I working with a 10 series? Am I working with an SPL? This is really the easiest way is just to look at the U-joints themselves. There's a few different indicators. The first is really, for me, the bearing cap retention style. So does it have bolts, holding in one of the sets of caps, or is it spring tabs? The second is going to be, does it have a grease zerk in the middle of the cross, or are they on the outer body of the cross? So this is again, another visual indicator when you're working through trying to find the right part numbers for, say, a U-joint, how you can visually identify which series you have. Inside of this U-joint on the 10 series, several different components. I always like to call out, and I'll probably say this a few times, these are the bolts that hold in the caps are retention bolts. More important was, say, the hardware when we're talking straps, that these are retention bolts and not installation bolts. I do have a slide that does show a failure if you decide to use them as installation bolts and potentially not have it seated properly. However, moving through the standard components, we've got the bearing cup, of course, the rollers, the spacer, the seal, and then the seal protector or guard. The SPL, similar in components. However, we do add a few additional pieces. We'll see the thrust washer, and then we also have a different setup here for the spacer, seals, and seal guard. Really, the SPL is the later, more up, I guess, technologically advanced U-joint. More commonly spec'd out in industry today. The 10 series is more of a vocational usage. But really understanding, okay, so we've got all these new components. Well, what does it really mean? What it really leads to is improved performance in the driveline system. And this is the only part of the presentation where I've kind of got, a little bit of branding. I try to stick to primarily explaining the systems as a whole. But I do think it's important to call out what the red box spacer really means and why is it, what parts of it lead to improved performance. And that's the cold form journal cross, heat treated, and case hardened bearing cups, the thrust washers. Really, it's that entire makeup of that U-joint and the processes that are used to build it up as to what's going to lead to that improved performance in the fatigue testing. One of the questions I often get asked is, what is a fatigue cycle? Well, that is a test in which our lab here in Maumee, Ohio, physically attempts to break driveline assembly. So in a fatigue test, one side of the yoke is frozen, we'll say, is pinned against a fixture, while the other side is hydraulically controlled. And you can watch this SPL 250 or 350 or whatever the series is flex. And there's enough hydraulic force to sit there and attempt to apply enough pressure to break it. And each series has its own rated testing efforts. And when you put it up against some of the competition, the SPL series, specifically here in the 250, does outperform. And that is based on the components that are used to build out that. Similar designs, or at least testing and performance on the 10 series. Again, just wanted to kind of touch base on this, the individual pieces inside of a U-joint and the engineering and the testing that is behind these. So switching gears, here we have two different yokes. We have a full round and then we have a half round. They'll both have the same part number, 6.3-4-1401. However, a half round will always have a -1X or at least a -1. That's what's going to be the indicator that you're ordering the correct yoke for whatever driveline assembly, whether it be part of a coupling shaft or whether it be an input or output to a tandem drive axle assembly. So just a little tidbit there that you can use to verify that, yep, we're getting the right part number, feel confident. Now, whether or not you're working in all makes, if you don't have access to that truck's build sheet, sometimes coming up with end yoke part numbers is going to be a little bit more difficult than if you have the truck's build sheet and you can run a serial number or whatever to identify the correct yokes. So I do have a QR code down there on the left next to the illustration of that end yoke. You can scan it. Earlier, the link was working. It will take you to this, what's called a jig. And it is a 3D AR setup where you can manipulate the screen and work around that yoke and click through those 13 different steps that I have outlined to kind of show you the 7 true steps of finding an end yoke part number. So the first one is to identify the yoke type. So by that, half round or full round. And in the image here that we've got moving is a half round. The series, we would use that ruler in which you'd place the half round nib, or I'm sorry, ruler up against the nib, and wherever it aligns on that ruler is going to give you the series. The spline major diameter, that's where we're going to use the micrometer. We're going to measure from root to root. We're then going to count all of the splines inside. I recommend using a marker to indicate where you started, because if you're like me, halfway through, you're going to forget where you're at, or at least where you started, and have to start over. So grab a paint pen, grab a marker, count those out, and then from there, you're going to measure the hub diameter, the through hole, and then the center line. And measuring the center line, I always recommend standing it up on top of a flat surface, and then you can use the digital caliper a little bit easier. Hopefully, it's got a part of it where you can measure a through hole a little bit easier. But it's 7 steps. You can then take all that information over to our Dana Aftermarket site, and you can filter it out. If you have one of our older paper catalogs, we've got the J300P-4, and then you can take all that information and kind of search it out that way. So you are able to use a few smaller hand tools here and work through identifying a yoke. It's 7 steps. If you have any questions or you want any more information at the end, you'll have my contact. Shoot me an email. I'd be more than happy to walk you through the process. So those were the basics. Let's get over to some maintenance. Things that we would expect you to do as far as an inspection process. The 3 bullet points here: proper driveline inspection should be performed as part of every scheduled maintenance program. That's a given. Normal maintenance and component awareness. That's where understanding what kind of components we're working on, what is good, what is not good. That helps us alleviate or reduce the opportunity for any larger mechanical issues that may cause that truck downtime. And then finally, the failure to perform normal maintenance may also void manufacturer warranty. That's the one I have to put in there as well. On spicerparts.com, we do have a literature library, and we do have a handful of inspection checklists and cheat sheets that are going to help work through the next handful of slides. But really what we're going to be looking at is all of the end yokes. We're going to be looking at any movement across our U-joints. We're going to be inspecting our slip splines for any kind of radial movement. And then, of course, the visual damage, bends, missing weights, things like that, and any hardware that is out of place or not properly torqued down to specifications. So where I like to start is on the hardware side of things. There's 2 different styles of straps. Now in the top left there, we have a half round end yoke that uses a pair of straps and then the retention bolts. The right side of the screen, we've got 2 different styles of those straps. We've got the cold form straps, which are in our SPL 140 and above. And then we have our stamped steel straps, which are SPL 100 and below. Each one of these has its own, series of need to knows. The cold forms, you can reuse those straps once they're removed, as long as they aren't damaged. The stamped steel straps need to be replaced anytime those bolts are loosened. So there is a certain amount of flex that is on one of those stamped steels. We need to make sure that those are replaced anytime that we are removing that U-joint for service. The bolts need to be replaced anytime they're loosened. The part numbers that we have listed out, that's again in the cheat sheets and plenty of our literature. Each bolt series has its own torque, along with part numbers and the straps that you can stock on your shelves. That way you've got everything ready to go for the next service. So I did mention, improper installation. What happens if I decide to use that strap as an installation strap as opposed to a retention strap? This is an extreme case in which that U-joint was improperly centered between the nibs before it was installed, and they used an impact to draw it down into position. That's what caused that damage there. So we've now got a broken nib, damaged end yoke, and the chances of that driveline assembly coming out is greatly increased, right? So we want to make sure that we are using the proper bearing installation processes, torque, and hardware to ensure that we are, working through these systems properly. Next on maintenance is always on the lube side. This is, a clear U-joint showing the grease path on a 10 series U-joint. So this is an older video. You can go on to spicerparts.com. There's an amazing 80s soundtrack that's going to go with this. It's about 3 minutes long, but we also fill up these caps with water, and you can see how it's better, it's better purging, I guess, as opposed to just watching it kind of move through in this demonstration. However, it is important to understand that a properly greased U-joint does have to purge from all 4 caps. And that's really important. If we get 3 out of 4, we need to figure out why that 4th isn't properly purging. Sometimes that's a matter of loosening the bolts. Sometimes that's a matter of removing the cap. However, if you do have an SPL that refuses to purge out of one of the caps, then you need to go ahead and replace that U-joint with a new assembly. So each maintenance cycle is going to be different based on that truck's either vocation or what its intended use is going to be. But we do outline the different mileage, expected mileage services here on Plenty of the Charts. When we look at U-joints as a whole, we do offer, and specifically in the SPL side, 2 different styles. We mentioned earlier the greasable and the non-greasable. So you can kind of see that, again, that smart numbering system comes into play, where a non-greasable U-joint is going to have that SF for service free as the backside of the part number. And then what all is going to come inside that kit? When you've got a standard U-joint here or SPL, it's going to have a grease zerk. You're going to have to grease that U-joint once it's installed. There's only enough grease installed into those cups to ensure that there isn't any corrosion during the shipping process. Once that U-joint's properly installed, you need to make sure that you grease it and all 4 cups are properly purging. If you have an SPL 140, say, service free, we do have a bulletin here, and yep, it's going to cover it. It's ensuring that we get all of that grease that's going to come with the U-joint installed into those cups before we install it. Because once we install it, right, all the cups are on, there's no way to add any additional grease. So we do have a process that's outlined and making sure that the reservoirs at the top of these cups are properly filled, and that we've also put a layer of grease around the inside of the rollers, ensuring that we use everything that's included in that packet. The 140s do come with their own tube, and inside that cross there are reservoirs. These require a little additional grease because the cups are smaller, therefore the reservoirs are smaller. So we need to, again, make sure that we're using these tubes properly and filling the center of the U-joint cross all the way up, using all the grease that's contained within that small tube, and then applying your final bit into the cups themselves. So really there's 2 different ways to install our U-joints, right? We've got our standard installation that has a grease zerk, in which you can go ahead and install it as it's packaged, grease it, install it in the truck, off you go. Then we have our service free, which requires a few additional steps before we put those cups on. So just make sure that you understand what style of U-joint you're installing, and that you get those greased up properly. The next is understanding that depending on the style, so in this case, if we're installing a U-joint with a grease zerk, in this case it's an SPL, we want that grease zerk to face in towards the center of the drive line. We don't want it facing out towards where the end yoke is, because really it comes down to clearance. Is there enough room to get a grease gun back in and attach that zerk to properly lube that U-joint up? So it's important that, yes, there is a right way to index the U-joint before you install it. Make sure you're following that as well. The final thing that we have on grease here is going to be the style of grease. Believe it or not, there are several different really base compounds that are used. Most commonly, you're going to see lithium, and that's going to be what we would expect out in the industry. However, the SPLs do have a specialized green grease. We do offer that, and that would be the recommended grease for the SPL series of U-joints. Also, what I've noted on there is that the center support bearings do not require any additional service. They are sealed and service free, which we'll cover here in a minute. And then also that our light or HT, which is our high torque series, that slip is lubed for life. There isn't a grease zerk like what you see on this yoke shaft down here. So when we're looking at center support bearings, really it has three main components. We've got our bracket, our cushion, and then the bearing itself. The bearing is sealed. However, one item that I do want to talk here briefly on is that midship nut. If you were to remove that, it's important to know that that is a one-time use nut. So if you are going to be servicing that center support bearing, make sure you order up that retention nut on that same PO so your tech can get that installed and torqued down properly. We do offer the center supports in two different variations. For most applications, we've got the solid rubber, which is going to be more on your vocational style of trucks, refuse, anything that's, maybe out in the fields doing work. And then we also have the Duratune, which is going to be the more common center support bearing that you're going to see out in industry. This is set up for reduction in noise, vibration, and harshness. So that Duratune is going to be the right choice on, say, line haul applications or city delivery, things like that. What might be new over, maybe some of the more conventional drive lines that you've seen through Spicer is our SPL light setup. So these reduce 17 components really down to 7. And the light doesn't mean it's light duty. It means that it's lighter weight and the reduction of overall joint complexity. So rather than having a drive shaft that has a center slip, the slip occurs between the coupling shaft and the drive shaft here at this joint, which is called a midship assembly. This is a serviceable component. However, they must be serviced as a pair. We do offer the center support bearings, which come with a service kit that includes the adhesive. We've got an installation TSB that's available online that you can download, print off. I also have some videos that are done, wrapped up. They'll be on our training academy here, and it's showing you the process. It takes about 10 minutes. It really kind of comes down to a little bit of curing time at the end, but we've got some tips and tricks on there about using a heat gun to help reduce that time for you. So nothing to be alarmed with. It's just a little bit different style than maybe what you're used to, but still definitely a serviceable component. So when we're looking at our center bearings and we're underneath the truck performing our routine maintenance inspections, it's also important to note the indexing on that bearing is to ensure that it's properly indexed and installed and that we don't have our end yoke rubbing against that cushion. So here would be an improper installation. Now, depending on how long this drive line was installed, we might be able to get up there and reposition it properly so that it will extend the life of the bearing. However, if it's been run like this for an extended period of time, likely the correct course of action is going to be to replace it. But it is important to know that there are windows on these center support bearings that do indicate the alignment of that cushion within that bracket. When we're looking at U-joints, the first thing I always want to make sure that I throw out there is that all measurements should be completed prior to grease application. So when we're doing our under truck inspection, we want to make sure that we are visually inspecting everything first. And then we are physically going to check for any kind of movement in that driveline system. So if we detect anything by hand, and again, we don't need to use jack stands or jacks or any kind of pry bars. If we feel it, then we need to go and get a dial indicator, set it up as we have imaged there on the left, and check it for movement. So if it's a standard U-joint, we allow up to 6/1000ths of an inch. If it is a service-free, that spec is 14/1000ths of an inch. So depending on how much is detected, then you'll need to want to go through, grab your indicator, and properly measure and note down what you found. So when we're looking at general inspection, here on the left is a proper, what we would expect to say is a proper installation. One thing that I always recommend to the guys that are out servicing fleets and see, the same trucks roll through the shop, is to use a paint pen. So once you've installed a U-joint, this paint mark not only indicates or aligns it to the end yoke, but it's also going to identify whether or not this U-joint cup ever rotates within the yoke. So it's, if during a service procedure, something isn't properly installed, you hit something excessively hard with a hammer, perhaps you stress or damage that yoke. We want to make sure that, we're catching that. So the use of a paint pen is recommended to quickly identify anything that may have changed within that driveline system. This one on the left, another part of the inspection, pretty straightforward, is inspecting for loose or missing hardware. In this case, the bolts are broken. One too many ugga-duggas with the impact there. Obviously this would be a pretty clear indication of what happened. But when we're looking at some of the other components, say the boot, these might be a little bit more difficult to detect. Does it have one clamp or two? Are the flutes intact? Is there any grease coming out in between the flutes? So expanding those boots, to ensure that everything is still dry and, intact. Some of the more difficult ones are any dents or any welds that may have an issue. But again, it's all visual and making sure that you inspect for weights and things like that. Spline inspection, anytime we have, two machined surfaces, we want to make sure that those splines are still properly mated and haven't worn. So again, similar to when we're inspecting a U-joint, we want to make sure that we have between 0 and up to 12 thousandths movement in that joint. So if by hand we detect a little bit of movement, get out again your dial indicator with magnetic base, set it up, spanning that gap, and give it a shake, and record your findings, and note those for your service team. On phasing, this is becoming more and more common out in the industry. Phasing is really the alignment of the yokes themselves. So on the left, we would call this in phase. This is where the yokes are going to be aligned one to another. The second is going to be out of phase, to where in this case, just for I guess a display example, this would be out of phase by say 90 degrees. However, it's not always going to be say 90 degrees. There might be one tooth, it might be three teeth, depending on that application. And this is used for the reduction in NVH. Some driveline systems have a little excessive NVH, and they work this out by way of moving the phasing on the driveline. So this is the SPL cheat sheet. This is kind of a rundown of everything we just covered in those previous few slides. It's got a couple of great pointers. Guys can print this off, keep it in their box, keep it at the counter, really just to help move through that inspection process. So we're going to switch gears now into vibration. And this is going to be starting to get into a little bit more of the in-depth side of the driveline system. We have 5 different types of vibrations that could be present within the driveline. We're really kind of focusing on those top 3. We'll touch on critical speed. I've got a quick little video on that. But really understanding, okay, so what's a transverse, what's a torsional, what's an inertial. You don't necessarily need to know specifically what these are, but we offer calculators that are going to help you understand maybe how to identify where or what is the source of a vibration that might be present within a driveline system. So really where I like to start is when we're looking at how does a driveline rotate, right? It's not a constant speed. Believe it or not, the angles of which, whatever is at either end will change the speed of that drive line. The higher the angle, the more of the oscillation in the speed. So what we're trying to do is reduce that oscillation, which is really the vibration. So we have a bunch of formulas, and you can do this math by hand, which I've tried and not too successful at it. But we do have a IJ900 catalog, which is going to walk you through what we're going to do next here with our online calculators. So how do we measure angles? What causes poor angles? Improper suspension height sensors. So if we've got one of the arms is perhaps disconnected or not functioning properly, we could have something that's been modified. So depending on that fleet, what kind of work has been done to it. Obviously, missing or worn components can lead to poor operating angles. To do this measurements though, we're going to recommend a digital really protractor. We offer the Angle Master. These are pretty easy. They got magnetic bases. You can put them on a driveline system just like this to kind of quickly work through these measurements. So let's jump in. We've got three main rules. U-joint angles should be greater than 1 degree, and we need that 1 degree to ensure that the rollers inside the U-joint are properly moving and distributing grease. We also want to make sure that the U-joint angles at each end are within 1 degree, and that angle should not exceed 3 degrees. So really, we're working within a pretty tight window to ensure the longest life of the U-joints. Once we start exceeding some of these numbers, that's where we'll start to see a bit of a degradation in the life of that U-joint. So before we can enter in some of these angles into our calculator, we need to understand what is an angle down and what is an angle up. So these first two images is if we were to look at the side of a forward rear carrier, yes, the yoke is up. However, this is truly an angle down because moving from the driving to the driven, we are sloped downward. Here on the second one, the yoke is down. However, this is still identified as an angle up. So as long as you can remember this as you're working through on the next couple of slides, then everything else will be pretty straightforward. So this is a snapshot from our homepage, danaaftermarket.com. We've got down underneath our technical resource calculators tab. The first one we're going to do here is just a real basic operating angle calculator. You can also scan the QR code or take a quick screenshot here. That'll take you over to a link to our angle calculator. This is the most basic calculation that we have, really. This is just understanding U-joint life. So again, moving from the driving to the driven from a side plane, we're going to determine the slopes using the center line and then calculate those using just the coupling shaft and the drive shaft as a two-piece. The inner axle will stand alone. So number of shafts, 2. The first one we're going to measure is going to be the transmission. So that has a downslope of 4 degrees. And this is all just a hypothetical just to have some real basic whole numbers. Your measurements are going to differ from truck to truck. Then we're going to measure our coupling shaft, 6 degrees, our drive shaft, 8 degrees, and then finally our axle, which maybe is sloped down 7 degrees. We put all that information into the calculator. It's going to give you U-joint operating angles. Are they within 1 degree of one another? Do we have at least 1 degree of operation? Do we not exceed 3 degrees? That's the real quick, down and dirty way of verifying are my U-joints in the correct angle. The next is if we're starting to track down some vibrations within a driveline system. So this one's similar, except we're going to add a couple of measurements, and that's going to help us identify any torsional problems within the system. So again, working from that side plane, we're going to use now from the driving to the driven, but we will need to know, say, operating RPM and then the driveline lengths. So number of shafts, still 2. I put in 2,500 RPM. Each one's going to be different, right? Depending on if it's 1,800, 1,200, whatever it is that you're feeling or having that concern. And then driveline length. So we're going to be measuring that from center of U-joint to center of U-joint. So in this case, coupling shaft, again, is 6 degrees down. However, that center line, the center line is 54 inches. And then our drive shaft, say, 62 inches. Again, each one's going to be a little bit different, but that measurement's going to happen from center of U-joint to center of U-joint with it in that running position. Again, transmission, axle inputs, you'll put all that in, and then it's also going to ask you for the final, which is going to be any offset. So is that driveline system centered or offset at all? In this case, straight ahead, 0 offsets, no additional measurements would be needed. We would enter all that into our torsional calculator, and it would give us any readouts. So if there is a problem, that calculator will flag it with red, and then you can start to manipulate some of those numbers to try to help to alleviate any of the concerns that you might have within that system. The next one is going to be on the critical speed. So critical speed is going to be, again, we're going to be measuring from center to center once we determine the style of driveline that we're working with. So style, is this a drive shaft slip between center? Is this a center supported coupling shaft? The tube dimensions, so what's the outside diameter? The series, so you can use a yoke ruler to determine that off of the end yokes. And then you're going to measure that center line dimension. So this is a video of critical speed failure. And it's really short, it's brief, but believe it or not, and this is from a commercial vehicle drive line. So the scale is, it's a 4.5-inch tube. You can begin to see it start to jump rope as it flexes due to over RPMs, over an extended length. That's why critical speed is such an important understanding of anybody who's out there and building drive lines, is making sure that we are going to put things into service that are, going to meet specifications. We do have some general dimensions that are available for you out in plenty of our literature. Just a real quick overview on, each length kind of based on an outside diameter in a driveline series. We also have maximum RPMs that are listed. Really just a lot of information for the builders, guys that are out there, working in the field on the aftermarket side. So when we look at the driveline analysis, this is where we start to dig into, yes, it broke. Why did it break? Two real main causes of failures are going to be down to shock load and fatigue. On the shock side, just picture a severe, or really an abrupt stop. So say like a rough trailer hookup, spinning wheels. So we've got no traction, then all of a sudden we get traction. That can definitely cause a shock load. Other guys, if you've been out in the fleet and out in industry long enough, you've seen trucks try to drag trailers around with frozen brakes. Not great. That's very hard on a lot of the drivetrain components. And then the misuse of the inner axle and differential lockout. So we're spinning, we're going to hit a button, and then whatever happens, happens. Not exactly the preferred method. Definitely can cause shock loads. Fatigue is going to be similar. However, this is more of more of an extended failure that may have maybe originated from an initial shock load. However, it's overloading of the vehicle beyond its rated capacity. So if this is, something that is, a vocational use that they're continuously overloading the system, can definitely cause fatigue. But let's look at a few of these shock loads. So this is on the trunnion or on the center part of a U-joint. So shocks are typically identified by this gray granular look. This is something that is, abruptly either stopped, typically running into an immovable object is the way that we like to phrase that. But this is what we would commonly see either after we've done our own internal fatigue testings or somebody out in the field who has damaged their driveline system due to driver error. This is similar. You'll see that same granular look to the components on an end yoke that may have, again, been exposed to a shock failure. And then overloading, these are, drive shaft tubing that has been overloaded. This is, again, catastrophic failure. If you look underneath the truck, it's not going to be a big secret as to what happened. But these types of failures often occur when a vehicle is either starting in low gear or pulling a grade at slow speeds, or again, just generally overloaded. Excessive torque, driving into a movable object, spinning tires to gain traction, things like that. Fatigue failure, this one's a little bit more difficult. You'll still see some gray granular. However, we also see what's called beach marks. This is where it's a slow propagation of a failure across that U-joint that then leads to an abrupt failure of the component. So you'll find that again through tubing or in the U-joints themselves, depending on where at on the driveline system the failure occurred. However, the overall look is going to be about the same. When we're talking U-joint installation, we've seen this, and this is improper installs. Hammers are not your preferred method of installation for a U-joint. We've found dents on the tops of caps to where, that's obviously damaged thrust washers. It's displaced the rollers internally, which then leads to catastrophic failure of the U-joint. This is a little DIY welding for anybody out there that's looking to modify their drive lines on their own. It's not recommended if you don't have the proper equipment or know-how. This is a failed driveline system after somebody attempted to make a repair. Critical speed failure. Here's an excessive RPM on a PTO shaft. So again, that's that jump rope effect. That PTO shaft obviously exited the vehicle once it reached its 88 miles per hour or whatever. However, again, critical speed does matter. This is a Fox body Mustang. This is more common, and I've personally seen this on a dyno stand. Again, it's over revving, its tires losing traction, and then an overspeed of the driveline system leads to an abrupt failure of that tubing. So all of these things do matter. When we're looking at the different styles of failure modes, here's one with improper lubrication. So on this end, we have the end galling, and on the opposite end, we have what's called spalling. The spalling is going, you can really kind of visualize where those roller bearings were no longer spinning around that trunnion. So this could have been an improper angle that led to that failure, or improper lubrication that led to an overheating of that U-joint. And then I just throw this one in because it's fun. Zip ties and duct tape for the win. So if you're underneath one of your fleet vehicles and you find this, thank a driver or thank somebody else who obviously was just trying to get back. But duct tape around U-joints is not going to be the preferred method of repair. So a few items here that we'll touch base on before we jump into some questions. This is on our uptime. So we do have our Spicer Righty Shaft program, and you can order these through the Kenworth team. These are driveline assemblies that are built by Spicer and delivered or shipped rather within 24 hours. The biggest thing is when we're identifying these part numbers as Ready Shaft is to ensure that we're ordering with an R. We do have at this point 14, almost 15,000 SKUs loaded into the system. But again, this is a genuine Spicer driveline assembly. Should you need to replace an entire assembly, we do have those available through the Ready Shaft program. If you don't have a part number, and you're trying to identify it, similar to what we were working through at the beginning of this slide deck, the Easy ID tool, which is on our website, danaaftermarket.com. We've got 10 steps. They're going to walk you through the process of identifying a driveline assembly. We've got videos on there with Matt working you through how to measure, where to measure from in its collapsed length, how to measure it in its driving or operating length, how to use a yoke ruler, all the information that you need to properly identify that part number is outlined in this Easy ID tool. Again, you can get to that on our website, which is free. Some of our online resources, really, this is just a load of literature, which is available on spicerparts.com on our literature tab. Drive shaft failure component analysis. So some of those images that I had in my slide deck are also outlined here. So if you're trying to determine how do I mitigate the opportunities for downtime, how do I not make sure that this failure mode doesn't occur again, we've got all of those listed here on these pamphlets. Feel free to download those and print them out. We also have service manuals. Now, if you want to get into the understanding of when to grease it, what style of grease, torque specifications, servicing U-joints, how do we get in there and press these in and out, we've got those service manuals available as well. The final thing, these are all those 4 websites. We've got danaaftermarket.com. That's the best one as far as looking up bill of materials for our driveline systems, for U-joint part numbers, center support bearings, strap kits, hardware. All of that's listed on there along with product availability. Then order that through the Kenworth team. After that, we've got the literature library, which you can click on. We have the spicerparts.com. That resources tab is going to be loaded with different videos and how-to information. Then we've got that literature drop down, which we've been talking about. And then finally, the training.dana.com. And that's where you'll find, myself and a lot of our training modules that would help you work through, any additional training on steer axle, drive axle, or driveline systems for either yourself or somebody new to the industry. So let's see here. I think, yep, that is going to wrap it up for me, Melinda.
All right. Well, I've just gone through and opened up the audio for everyone. So if anybody has any questions and you want to just unmute yourself by clicking the audio button on your screen, feel free to jump in with some questions. If you'd prefer, you can also just drop them in the chat or the Q&A as well. In the meantime, I'll just remind everyone following the session, I will be sending out an email that has a link to the this video out on YouTube once it's posted. And I'll also include some of the links that Scott mentioned as he went through his presentation today as well.